Okay, so let's move on. And well, in this problem, we know that well, we have an initial velocity, an initial I don't know what's it called, frequency, and we want to know the angular acceleration, assuming that thing is constant. Okay, so from that, we first need to get like the angular velocity. So from here, we know that 500 revolutions per minute are equal to 50 thirds of pi because of the previous problem. That's why. Radians over second. And there we go. Angular acceleration, assuming that thing is constant. Well, we know that alpha is equal to uh, delta of angular velocities over time. And that is equal to, well, final omega minus initial omega over final time minus initial time. So we know that this thing starts from rest, so the final velocity, angular velocity, is going to be 50 thirds of pi minus 0 over 5.5 seconds minus 0, and this is going to give us 9.5199 radians over second squared. Okay, that's the first one. Now we need to know this part A. For part B, we need to know the total revolution. The total revolutions the disk makes in that time. So this time I'm going to write in orange. I'm going to write B all over here. And I'm going to know, well, for that we use another formula that we used to use, and it's like this one, as initial angle plus initial angular velocity times time plus a half of the angular acceleration t squared. We know this thing starts from rest, so this guy is 0, and this guy over here is 0. So we know that this angle, it's a half of 9.5199, the value we just like got, and times t squared, we just use parentheses here, times 5.5 squared. And that is a, well, you can write it in two ways, either 275 over 6 pi, or you can write it as 143.98. Both of them are correct, and the unit is radians. Is this my answer? No. I'm just giving an angle, okay? I need to transform it into revolutions. How do I transform it into revolutions? Oh, that's very, very simple. We just need to make a conversion. I know that this is 143.98 radians. We know that one revolution is equal to 2 pi radians. And that is just let me compute it. Here, 225 over 6 pi over 2 pi. That is, you can write it once again. Well, you can write it in just one way. This is 22.91 revolutions, okay? So it has turned almost 23 times. So this guy over here is my second result. And finally, how far? This is the distance, okay? You remember that I told you to write down the thing of arc of length? Now is the moment of the arc of length. We'll just write it here downwards. We know that the radius is going to be 6 centimeters, so we're going to write 0.06. Okay, so we need to know how far that point has traveled, and that one's actually very easy. We know that the arc of length is going to be equal to the radius times the total the displacement in theta. We know the angle is 0.06, and we know that the angle is 143.98. So this is gonna be either 11/4 of pi meters, or let me write the equal sign properly, 8.63 meters. Both of them are correct. Okay, so this is pretty much the first real problem we face.